Hello again, everybody. So I wanted to help you guys with the WebAssign problem with the runners in the flagpole. So this problem is very similar to the trains from Winnetka and Chicago meeting, like we did in the example problem in class. But it asks an additional question beyond just how much time does it take. You actually have to find the position where they would meet at, and then also find out that relative to a flagpole, so the displacement relative to a random location. This is very tricky to organize all in your head, so you'll notice the best thing I did is to draw a picture. And it really is hard to do without this. I would even struggle organizing all the information. So if you look at the picture, you'll notice that I actually have a prediction where they will meet. I was able to assume this because if you look at runner A on the left, they are not only closer to the flagpole, that runner is actually going to travel faster. 5.8 kilometers per hour compared to runner B's 4 kilometers per hour. So since they are not only closer to the flagpole and running faster, I know that they won't meet until or at least runner A is on the right side, the east side of it. So I have a general idea of where they will meet, but that exact location and its displacement relative to the flagpole, I need math to do this. So as we learn with these system of equation problems with two objects, there's two scenarios. They're either both going to travel the same distance if they start at the same place and end at the same place, or their distances traveled will add up to some amount. This one is the latter of the two. It's basically the displacement traveled by runner A and the displacement traveled by runner B must add up to the total, which if the one distance is 2.8 and the other is 9, the total between them is 11.8. Now, so I'm not lying to you guys, I'm kind of using poor vocabulary. With this type of question, it's easier to not care about direction. So instead of saying displacement, you'll hear me actually say distance, and same thing with velocity, I'll say speed, because those are comparable in terms of they tell you how far or how fast it's going without a direction, and that is better for this. So if I can figure out the distance traveled by runner A and runner B, it should add up to the total, which makes sense. What we learned though in the train question though is that we can't do much with this. So we had to actually substitute the kinematic equation for displacement, which said the velocity of A multiplied by the time is the same thing as the distance of A. There is no 1/2 AT squared because this runner is not accelerating. So the same can be done for runner B. And this should still add up to a displacement of 11.8 kilometers. So I'm not going to do it. My numbers are different, of course, and we did this in class, but you can actually solve for the time it would take them to meet. This question, however, doesn't want that time as the final answer, but we still need it. We need to actually figure out where do they meet, which is marked in the picture by the black X. If I now know the time, I can actually use this with one of the individual equations. So for instance, maybe the displacement of A, or distance I should say again, excuse me, is equal to the velocity or speed of A times time. If I now know the time, I can plug that into this formula and find out how far does runner A actually travel. Oh, and it did a straightening effect. I didn't want that. So if I plug it into that equation, it's basically going to solve this for me. Understand though, that is not how far runner A is from the flagpole. That is how far they are from where they started right here. So if I actually want to figure out the displacement from the flagpole, which again is shown in black, the X to the flagpole, I'm actually going to have to take this value I just calculated for distance of A and subtract 2.8, because if I show you even down here, the difference between them is then going to equate to the flagpole to the X. So go ahead, try that. Hope that helps, guys. Good luck.